Welcome to Sunday's edition of Cracking the Cryptic, and today we've got a puzzle by one of the constructors that gives me the fear. This one is by Gliperal. Now we've had this requested by 2 or 3 of our patrons on grounds I believe that it is very, very tough indeed. So I'm anticipating a very long video. It's called Anti-Night Between Lines, which is really just a description of the rules we're going to have to employ, and I'll read them out in a moment. A couple of things to mention first before we do that. We have released a bonus video over on Patreon where I take on a solve of a puzzle Mark actually covered on the channel. So I use some devious trickery to get through that puzzle. I think it's interesting. It's by Samantha Mukherjee, and it has, I mean, it's actually an incredibly beautiful puzzle. And I think some of the devious trickery brings that out. So if you're interested in that sort of thing, check it out. It's on Patreon right now. Also, of course, Clover's TED Talk on how to set Sudoku is also available. And just this morning, we have released the 3rd edition of our podcast. So in that edition, Mark and I talk a bit about some of the Sudoku and puzzle competitions that we've been in over the years. So hopefully you'll find that interesting. That's available both on the YouTube channel and on various podcast delivery mechanisms. And with all that said, let's get on with Gliperal's puzzle. What are the rules? Well, normal Sudoku rules apply. Good. Cells separated by a knight's move in chess cannot contain the same digit. So imagine this square's a 1. Now, if it was a chess knight, it could jump to a variety of cells around the grid. All those cells outlined in blue. And therefore none of these cells outlined in blue can contain the digit 1 in this example. So let's look at more examples of that. This 5 could not be in either of those squares. So if you try and put a 5 here, they're a knight's move apart. That breaks the rules of the puzzle. So that's how knight's move constraints work. Now there's something else going on here. Digits on blue lines must be strictly between the digits in the circles at either end. So this is the between line constraint, and this is very much a constraint I have not got my head around yet. So what this means is, let's imagine this square was a 3 and this square was looks like it can be an 8. Those two squares would have to lie, well, they'd have to be selected from 4, 5, 6 and 7. We couldn't put a 3 on here because it then 3 is obviously not between 3 and 8. We could put 4 in there and 7 in there, I think. Something like that would be fine. You just have to make sure those digits in the middle of the line are between the digits in the circles at either end. And obviously in this puzzle we've got this weird sort of shape. It's actually symmetrical, isn't it? Which is presumably the key to the solve. Anyway, I don't know how it works, but I'm hoping I will find out over the next several hours. To play, you get to click the link under the video as usual. Now I get to play. Let's get cracking. And what do we do to get cracking with this? Well, something that I'm wondering about, which actually is something I was looking at yesterday with Ard van der Wetering's puzzle on knight's moves. That was knight's moves and arrows, and it occurs to me that this works in a similar way, in the sense that if we think about this cell for a moment, let's make it red, and ask where this cell appears in the middle box, what we do know is it cannot be on its own between line, because if this is an 8, you can't put 8 on the line, obviously, so it's a bit like an arrow in that respect. So you can eliminate red very easily from those squares. You can eliminate it from those 2 squares by knight's move. So red lives in one of 2 places in the box, and I'm guessing that that might be symmetrically true for all of these cells around the central box. Let's just double check that. Yes, okay, this one certainly works the same way. What colour should we use? Use purple for that one. Purple has to sit in one of those 2. This one can't go on its own between line, can't go there, so we'll make that one green. And we'll make this one, what colour's going to stand out against green? We'll use, I don't like to use orange, that's going to offend me. And I don't really want to use yellow because I'm going to have to change the colours. Sorry. I'm going to use yellow there because I can see yellow against red. And I'm now going to use purple here because I can see purple against green. There we go. That's better. Right, now, what's this telling us about the state of the world? We've now got... I have no idea is the answer. So we now know that some of these digits around the edge... well, okay, there's something simple we know now, which we didn't know before, and that's that all of these digits are different, because they all live in the central square, and they don't map to the same positions, do they? Or is that true? What about that square and this square? No, hang on, that might be wrong. So maybe... No. Oh, I'm not sure. I'm not sure. Can this... No. I tell you why it doesn't work. It doesn't work because of this between line going over the top, purple and green are different. Therefore, purple and green can't both be in this position. Therefore we know purple and green are different, and we definitely know purple and green are not the same as red and yellow because they don't map to the same cells in the central box. And the same by symmetry is true of here because of this between line. Right, goodness, that took a long time even to get a simple deduction. So we know that all of the colours are different digits. So maybe we have to... yes, something simple. Right, look at yellow. Now, yellow, if this was yellow, if this was the real yellow and this was not yellow, let's imagine this was the case, the puzzle's broken. Because where does yellow go in this row? It's got to be in one of these three squares. We know yellow is not green, so it's not here. It can't be here because of knight's move, and it can't be 1 because it's on a between line here. And you can never put 1 or 9 on a between line. It's a bit like a thermometer. The 1s and 9s can absolutely go in the circles, but never on the lines. So this is not yellow, which means that's yellow, so it's not red, and that means that's red. And that means yellow in box 4 is in one of those two squares. I'm just realising how hot it is today. I forgot this. Reds go in these positions. I know some of you don't think it's hot in the UK at the moment, and you're probably right, but I think it's about 24 Celsius, which is quite hot. Now that must be red. We don't have any luxuries like air conditioning in this country. Now, have we learnt about the world from here? Well, now I'm going to try the same trick again. So green, if this was the real green, green is not yellow, so green couldn't be here by knight's move. Green would have to be 5. Green would have to be 5. What's wrong with that? I'm not actually sure. It doesn't work quite the same way, does it? Because 5 absolutely can be on a between line. 4, 3. Now also, if green was 5, purple would be 1 or 9, because there are actually, you'd have to put 3 digits between the 5 and some other digit, which would have to be a 1 or a 9 in purple. That would force purple off. This, good lord, this becomes very, very constrained. If purple is 1 or 9, it can't go on that between line. It would have to go here, which... That does actually... Well, I think that looks plausible to me. So I can't rule green out from here. Now, if green is there instead, purple becomes here, and then purple can't go there by knight's move, so purple would live at the bottom of the grid. But this is much worse, because there are no digits looking at this cell, so we don't actually learn anything about purple. Oh, good grief. How on earth do you start this puzzle then? What am I not understanding about this? Probably a lot of things. Red. We already knew that. I was about to conclude that red couldn't be 1 or 9 because it sees 1 in that row and 9 in this row. But of course red could never be 1 and 9 because it's on the between line. Yellow also can't be 1 or 9. That's a little bit, well, it's a little bit more sophisticated because yellow here, this yellow sees the 9 and this yellow sees the 1. So yellow can't be 1 or 9. Why does that matter? If yellow can't be 1 or 9, does that do something useful? Does that mean... Right, that does mean that red is not 5, I suppose. Because if red is 5, let's just think about that for a second. I think that's right. If red is 5, this between line is telling us that this yellow digit has to be... well, we've got to go... we'd have to... let's say we're descending. We'd have to go 4, 3, 2, and then this would have to be a 1. Which it cannot be because of this. And if we go up, we'll go 6, 7, 8, and this would have to be a 9, which it can't be because of this. So red is not 5. And yes, that does mean it might well... oh no, red can't be 1 or 9 either. So red is now either... this is the worst Gliperal-esque pencil mark I think I've ever done on the channel. 2, 3, 4, 6, 7, or 8. So this is 2, 3, 4, 6, 7, or 8. So this is 2, 3, 4, 6, 7, or 8. I realise I've just said that same sentence several times in a row. I'm sorry. I'm just trying to think about what this means. It means we know there's a relationship between red and yellow. So red is either a modestly low digit or a modestly high digit. So it's either 2, 3, 4, it's in that set of 3, or it's 6, 7, 8, and it's in that set of 3. Now whichever one it's in determines sort of what sets are available for the yellow. If this is 2, 3, 4, the yellow can't be a low digit because we have to go 4 different. Maybe I should do this in terms of algebra. Is that sensible? I'm not sure. If this is 2, 3, 4, this has to go upwards. X plus 4 minimum. Then x is on the between line. So this is above x, and this would have to be below x. So this has to be a maximum of x minus 1. A maximum of x minus 1. Then what's green got to be from there? So at the moment I'm just exploring. I'm thinking about what happens if this is a relatively low digit. So 2, 3, or 4. I'm saying x is 2, 3, or 4. This has got to be at least equal to x plus 4. This has got to be a maximum of x minus 1, which means it's a low digit. It's sort of an extremely low digit because it's got to be lower than the red digit, which means green has got to be 4 different from that. So green can't go down from there. Green's got to be a high digit. Green's got to be a high digit. And this is a low digit. But that... no, that breaks. That breaks if... well, it breaks if that is purple. Hang on. Let me just try and think about this. So if this is 2, 3, or 4, and it's right, what we've got to do here, I think, is imagine. Let's forget about these given digits. So we're not going to rely on any of our logic on the givens. That way, it doesn't matter whether I pick 2, 3, 4 here or 6, 7, 8. We can generalize the result. So if this is a low digit, this has to be a higher digit. Because we can't, let's just prove that to ourselves. If that's 4, we now know yellow, it can't be lower. 3, 2, 1, this would be a 0. Impossible. So whether this is 2, 3, or 4, this is definitely a higher digit if we select 2, 3, 4 as the starting point. So this is a higher digit, which means this must be lower than x. Because this is a 2, 3, or 4, this is higher. For the between line to work, this is lower than x. Now, if this is lower than x, this square has to be higher than x, because we can't carry on going lower, if you see what I mean. There aren't enough digits left. So if this is maximum at 4, this is maximum at 3. And if we go 2, 1, 0, minus 1, that doesn't work. So this is the point. This has to be higher. And it has to be at least equal. Well, no, it doesn't have to be at least equal, because this could be a much lower digit. This could be 3, 2, and this could be 2, 1. But it has to be 4 different from this digit. 1, 2, 3. Sorry, 3, 4, 5, 6, 7. So ignore this, because this is not relevant to the logic we're performing here. And this is the interesting thing, is we're simultaneously here. We've proved that whatever the starting point for this is, whether this is high or low, if this is a modestly low digit, this becomes a modestly high digit. But the point is, this is lower. This is always a lower digit than x, or it's a higher digit than x if this is a moderately high digit. And that means it can never go on this line. Because to go on this line, you can see it's just not going to work. It needs to. It's just the wrong parity, or parity is the wrong expression. It's the wrong size. So let's just. I don't feel I'm proving this very elegantly. And no doubt, if I do get through this puzzle, somebody will be able to prove it elegantly. But I do like to try and just convince myself of things absolutely. So let's just do this once more time using algebra. If this is x, and let's say it's modestly low. It doesn't. Oh no, let's say it's modestly high for a change. Modestly high, it's x. So it's 6, 7, or 8. We therefore know that this must go lower because it's 4 different. So this, if this is x, x minus 1, x minus 2, x minus 3, x minus 4 is the maximum value of this. So we've got a line here that's x minus 4, x here, so this has got to be greater than x. So this has to be x plus 1. So this has to be x plus 1 if this is true. Which means that, let's think about this. This is a 6, 7, or 8. This is a higher digit, and this needs to be a higher digit still. While at the same time being 4 different from a highish digit. There's not enough digits in the world. There's not enough digits in this Sudoku to make this work. And this is gorgeous. Probably because it rules out purple from that square. And that means purple is here, which means green is here. Oh, and this is good. This is good because I've remembered about 25 minutes ago, I recalled that if these were green, this can't be green. So 5 is green and we have digits. There we go. There we go. We're off and running. And this is not a straightforward puzzle. I don't know how people like Gliperal come up with this. I mean, it's just crazy. Right, what have we actually learned here? Have we learned anything about the size of red? No, but what we have learned is about the size of purple, because purple has to be 3 different from green. So this purple duo here are now 1s or 9s. So maybe I carry on colouring purples. Look, purples go into those squares. Oh, if purple was here, we would know. We would know what purple was because of this 9. Let's colour in that one as well, because that's now green for sure. I think I removed the pencil mark from there. That's distressing me. It's too weird. Now, what do we do with this newfound information? Has the puzzle become easier? The answer to that, unless I'm missing something, is no, it hasn't. I mean, what on earth do you do with this? I presume you can't do anything with... Green is up there, because it can't go on its own. Between line and knight's moves, etc. rule it out of places. Okay. Oh, good grief. Right, we are... Right, we're going to have to really pay attention. This is bonkers. Right, where does green go in this box? And the answer is I have not got much of a clue. I know it's not there. I know it's not here because of knight's move, and I know it's not here because of knight's move. So it's in that domino, which means it's down there somewhere. But apart from that, we've not now managed to place green in row 3, and it's not in those squares. So green is in one of these 3 squares, and it's not there, and it's not here by knight's move. So green, the 5, is on this between line, which means green is in this domino down here. Now, can it be there? What do we actually know about red and yellow at this point? We know red is on a between line. And we know red is at least two digits. Well, I suppose it's at least 3 digits altogether away from 5, because if this goes downwards, it would be 4, 3, 2 or 1. And we know it can't be 1 because red cannot be 1. Oh, hang on. So if this goes the other way, 6, 7, this would have to be... Ah, okay, red is 2 or 8. Good grief. Okay, I hadn't spotted that, sorry. And I think that's just straightforward application. Once this is 5 and you have to fulfill this between line, and you know that red is not 1 or 9, it's got to be 2 or 8. Let me just double check. There is no more we can do with 5s, is there? I don't see anything. So let's come back to thinking about reds. What do we now know about red? Is red on this line? If purple is 1, yes, this is actually really interesting. If purple, whatever purple is, sort of defines what this digit is, because if purple is very low, or does it? Is that... Actually, that might be wrong. Hang on a sec. If purple is very low, let me just, in fact, I'm going to visualize it like this. If purple is low, this cannot be, yeah, this cannot be 8, can it now? Because if it's 8, this has to be 9. And similarly, if purple is high, now I'm claiming this cannot be 2. Because if it is 2, you have to make this 1, which makes this 1, which is impossible. Good grief. Right. So, we have actually got something here, I think. Red is exactly 1 digit different from purple. So if purple's 1, red is 2. If purple's 9, red is 8. And that is very interesting all of a sudden. Oh no, it's nearly interesting. I was about to say it's very interesting. It is sort of interesting because we can ask the question, does red have to make an appearance on this between line? And the answer is yes, because if this is 1, we know these 3 squares are 2, 3 and 4. One of them will be the 2 that red is. And if this is 9, this will be 6, 7, 8, and one of them is the 8 which red is. So we need to put red on this between line, and it's therefore got to go in one of those 2 squares, I think. Which doesn't actually seem to do anything. So yellow is sort of just the opposite of red, isn't it? That's what we now know. If this is 2, this has got to be a modestly high digit. If this is 8, this is a modestly low digit. Because it can never be 1 or 9, but it must be the other size. Okay. Can we do any more trickery then with knight's moves? We can lock... Yeah, we can actually. Red in box 4 is not there by knight's move or here by knight's move. And it's not yellow. We know red and yellow are different. So red is in that domino, which is a surprise to me. I don't know whether that's correct, that it should be surprising to me, but it is a surprise to me. So red is in this triple. Now look, red, where does red go in box 7? And the answer is, I don't know. But, again, red can't go here by knight's move, and it can't go on its own between line. So red, and it can't go there, actually, by knight's move. So red is in a little L-shaped region. And again, I'm asking the question about the sort of empty flank here. Where does red go in column 3? And red has to be in this... No! Well, I was about to say red has to be in this domino, and that's almost true. Well, it is true, but I can do better, I think, because of this red. So red is now in those 3 squares. This red says it's not here. This red says it's not here. Red goes there, which means red is not here. And red is therefore here, so it's not here. Nori nori. Red... I don't know if that keeps going. That is absolutely remarkable, though. We've now got actually some progress on reds. And I'm not sure that we can't go further. It sort of feels like the reds are constrained down in this part of the world. This puzzle is absolutely mental. And I'm sort of struck by the fact that many of the digits, many of the places for the digits, the colours I've managed to place, have come from nowhere, which is a bit disconcerting because I'm not sure that I'm not missing things with, for example, I mean, it doesn't look at all to me like I'm going to be able to place any more yellows in this grid. But maybe if I study it long enough, I could do. Surely not. Surely not. Yellow. I suppose yellow in box 7. Let's just think about that for a second. Yellow is not 9 by knight's move, so it's not there. Yellow can't go on its own between line, and yellow can't go there by knight's move. So yellow overlaps with red down there, which is better than I thought it would do. Now yellow may be in this box then. Yellow is not red. Yellow can't go here or here. I don't believe this. Yellow, look, I think is in one of those squares. And again, the same question arises. Where does yellow go in row 7 now? It's got to go in one of those 3 squares, and it can't go here because that would rule yellow out of box 6. Yellows are in those squares, which means yellow is in the domino at the top of column... Oh, this is a bad one. I won't see that. Yellow and green are very close in terms of my eyesight. Golly, if I can do only a little bit more with yellows, I might be able to place yellow, which is amazing given what we had in yellows. Yellow, if I could get rid of that square, that would be yellow. I would know that that was yellow. I'm not seeing how to do this. Yellow, yellow, yellow. So yellow's in one of those positions. I don't think it's good. Okay. Do we have to do more between line logic then? That's possible actually, because there's probably more we can do here. What can we think about? This one has become useless. Once you get the 5 in the middle, there's no constraint on the outsides basically. If this is, well, this is 5. If this is 1, that's 2. Ah, those are 3 and 4. Oh, I see. Right, sorry, I've missed something here. I've missed something. Okay, let's come back to this between line, especially this square. This square and this square are the same. So if this is a high digit, if these are both 8, then this is 9 and this is 6, 7. But because this is 8, that's 6, 7 as well. These two digits and these two digits are the same digits, and we can see immediately what that means. Because if these are the same digits, what's this digit? Well, it's not that one. So those two digits are the same digits. I think I'm going to have to resort to blue, which is going to be very hard to see with the between lines, but I'm running out of good colours to use. And then these two must be the same. I can make those orange, actually. Ugh, it's all getting very tricky to see. But, look, blue, just by Sudoku now, blue can't be there. So blue goes there, which means that's not yellow all of a sudden. Now, does that matter? Did we... I can't remember what we were thinking about yellow. It feels like a long time ago. But yellows are now in one of those two squares, which is interesting, look, because now I've got yellow dominoes at the top of columns 4 and 8. So yellow is in one of... No, yellow is placed in box 1 there, which is beautiful. Look down here. Yellow is not there. So yellow is placed here. Red is placed here. I don't believe it. Red is placed here. This has become a red. We know that red is 2 or 8, so I'm definitely putting that in. This has become yellow now, which means that doesn't seem to be possible for that to be yellow anymore. Which means this has become yellow. This yellow sees that yellow by knight's move, so that's now yellow, which means that's not yellow. And I don't... Have I placed all... No. 1, 2, 3, 4... I've done 7 yellows out of nowhere, and I've got some yellow nonsenses up here to resolve. Okay, but let's come back to reds again then. Can I do more with red now? The other thing I've not looked at all is orange, or I've not really looked at blue either. This all came from just being able to place a blue there. Red, let's come back to red. So red is now in one of 4 positions. I think that was what it was before. Blue. Sorry, just give me a second to stare at this, just in case there is some weirdness going on. Blue is on this between line. I'm almost tempted to write in the options here, actually. What's yellow? Yellow is this one. And yellow depends on... Yellow depends on that one, doesn't it? Oh dear, let's look at orange. I don't think I've looked at orange at all. Orange can't go... Ah, yeah, okay. Orange in box 2, look. This orange rules the roost over those squares. So orange is in that... Well, it's not a domino, but it's in one of those two. So orange is in... Orange is placed. Orange is placed in box 8 now. It's got to be in one of these 3 squares. Yellow is placed, so this yellow is correct. This can't be orange because it's a knight's move away from orange. So that is orange, which means this... Oh, this is gorgeous. I've done it. I've done it. Look, this is 1 or 9. We've forced purple into this square in box 8 and it sees 9. So that means purple has become 1. And now, yes, lovely. Now, how do we make this between line work? This has got to be 2. So red has become a 2. Red has become a 2. These 2 squares have got to be 3 and 4 to make the between line work. We know that orange is 3 or 4. Orange is 3 or 4. Okay. What does this mean? This is the next question. I'm not sure. I can't do more with orange, to be honest. Look, what about this box and where orange goes here? Because orange is ruled out of these by Sudoku, but this one does more work by knight's move. Orange is not equal to 1 by the power of simple maths, because it's 3 or 4, and 3 or 4 does not equal 1. I think orange is there, I think, which means that place is red here. And this is a 3 or a 4, and that means orange is in one of those 3 cells, which is probably we can do better than that if I can work out something about that. Orange down here can't be here, so orange is in... No, where does orange go in box 9? It's not there, and it's not here by knight's move, so orange is on the between line, which is a 3 or a 4. Orange is now... Orange can't go here by knight's move, so orange is in that domino in box 7. I can do better. I've just spotted something else. Look at this orange. Now this orange rules out these 3 squares from being orange. Now the orange in box 2 is in one of those squares. Now you can't, if you've got an orange in these 2 squares, you can never put orange in either of these 2 because it rules both out because of the knight's move. If this is orange, it rules that one out by normal Sudoku, that one by knight's move, and obviously this one works the same way. So where does orange go in this box? And the answer is I've not got a clue. But I do know it's in one of those 3 squares, I think. And if it's in one of those 3 squares, I've not put orange. Where's the orange going in column 3? The only available orange cell is this one. So these are not orange, and this has become an orange. And this orange sees that orange by knight's move. I almost feel like Gliperal must have just been laughing as he set this. Now, hang on, that's yellow. I think I maybe had that yellow before, and then maybe when I penciled the oranges in, I didn't realise. Because I can see this is not orange now. So the orange has moved up here, which means that's not orange. And therefore this is orange. And now, how many oranges have I got? The answer is many. Hang on, I need to do colours to actually highlight that properly. So I've got, oh I see, I've got 7 oranges that I've got, and I've got a domino in boxes 1 and 7 to go, so that's going to be probably troublesome. I can make 1 purple. I'm going to do that right now. Maybe 1 in box 3. Yes. Yes. Where does 1 go in box 3? It's not here, it's not here. By knight's move, it's not those two. I think it can only go here. Now that is interesting because it gets rid of... yellow from this square, and it looks to me like yellow is therefore forced here, which is going to force this to be yellow. So I think we've now done our yellows. This now is not green either. So green is definitely there, which means green is... Oh, this is good as well. Look at this. Now green is in this domino in box 9. It seems to be in that domino in box 7. So again, where does green go in row 7? It can't go there. That's got to be a 5. This is quite extraordinary. No, okay, I was just wondering about where 1 goes in, I should, of course, keep to colouring. I was about to resort to numbers. That would be very, very silly. Where does 1 go in box 9? This domino can't be 1. We place 1 at the bottom. Where does 1 go? Aha, got you. Where does 1 go in box 7? Not here because of knight's moves. Therefore, it seems to overlap with an orange domino. Now, if it overlaps with an orange domino, we can't also have red interrupting this arrangement because we know these must be orange and purple. So red is ruled out. Red sits in the corner. Naughty red. Hang on, have I done it? I must have done all the reds. I've got loads in the grid. No, I've not done a red over here. That seems to have to be red by little old Sudoku. So I've now... Oh, what about 1? Yes, 1 is in one of those 2 squares. That's almost good, isn't it? Yeah, it is good. It is good. Because now... Yes, same question again. Where does 1 go in column 3? It's not there, it's not there, so 1 must be here. Which means that square is not a 1. We could have eliminated that very quickly. 1 is now... We've done 7 of them. Okay, we've got dominoes on 1s left. Okay, and then what do we do next? We pause for breath, do we? And we think. And what do we think about? We think about... Do we do more knight's moves? Do we do between lines? I've still not really thought about the value of yellow. Maybe that's something I should think about. Yellow is... So this is 2. So 3, 4, 5. Yellow is at least 6, but it can't be 9. So it's 6, 7, or 8. Well, it's not 7, though, because yellow seems to be there, and that's got a 7 in the box. I can't actually see any 6s or 8s in the grid, which might be my mistake. But I think yellow is 6 or 8 then. And I've placed all the yellows, so I can put 6s and 8s in all of them. Now, if yellow is 6, what on earth do I put on that between line square? Oh, that's it. Oh, good grief. This is just superb. If this is 6, we have to fill this between line with the exact digits 3, 4 and 5. This square sees 3, 4 and 5, so that's wrong. This is 8. Yellow is 8. That's weird, actually. That's weird, because although it's magnificent, it doesn't actually do... Because I had all the 8s, it's not actually done anything. It's a nice digit to get, but because it sort of lets the pressure off this between line, which now has to be... So this square now has to be a 6 or a 7, because it can't be 3, 4 or 5. Do we know... I don't even know where blue goes in this box. Maybe I can find that out. Let's go back to blue, maybe. Blue's in one of those three, is that correct? Can't be here, and everything else seems to be fixed. So blue's in one of those cells. Yeah, oh, well, maybe. Blue, oh no, it's wrong. I was about to say something incorrect there. For some reason I thought that blue couldn't go in this cell, but I don't think that's right. I think blue can go in this cell. So although I can rule blue out of those two squares, oh, blue is on the between line then, because this is a filled domino, just a weird one. This is like a 1 and a 3 and a 4 in some order. So this blue gets rid of those two, forces itself onto the between lines. But unless I'm mistaken, we don't know how that works. Oh dear. So we have to do more thinking. That's this is beholden on us. We've got to do more thinking. How shall we do this thinking? Are there any digits that I've not really exploited enough? Ones. I feel like I've done... I can't see how to resolve those ones. If it's resolvable, apologies. The 2s I've done. What about the 3s? Or the 4s, whatever these are. Is there a knight's move? I don't see anything. So let's try the blues. This looks like the digit, or feels to me like the digit I should be focusing on, because I really haven't done much work with this. I don't know how to do it though. What do we do in order to make more progress here? We have got to... Is this seeing anything? It's not seeing anything. It's not fair. What about... Okay, let's look at blue up here. So blue is either there, or there. I do not see a problem with any of those. I really don't. Have I missed a trick? That's the problem. It would be so easy to miss a trick on this puzzle. I can tell you that. This does not feel like a simple puzzle at all. But if it's not blue that we look at, what is it that we look at? I tell you one thing I can look at. This 5 is seeing that square. That's something I've missed, so that can't be 5. This has become a 5 at the bottom of the grid. That's not a 5 anymore, which means... See, look at this. That's one deduction that I missed, which was that this 5 could see that square. And I've no doubt it's been causing shouting, but it's, you know, it's one missed deduction that caused a lot of... In fact, it does loads of work. Look at this. This becomes a 5. I've still got 5 dominoes up there, but the key thing is this has become a blue. So this is a 3-4, and this blue sees those two squares. So that forces this to be blue. If this carries on, I think... Oh, I don't believe it. It does. Look, that's a blue. Now those aren't blue. Oh, I'm weeping inside because I know I'll have been shouted at for this. And it's not my fault. Well, it is my fault, but you know what I mean? It's just tricky. If I'm not looking at the same things that you are, it becomes difficult. Now, what have we got now? We've got all the blues. I know we've not put blue in this one. Blue goes there. That's on the between line. Oh, look at this. This is it. This is it, because this can't be low. This cannot be a low number. 1 and 2 are not available. So this must be a high number. And if this is a high number, this must be higher than this digit, because we have to make sure it's between this digit and this digit. So this is what is disambiguating the 3 and the 4. So we've now... go on, let me do it. Those become 4s. Now be careful with orange, because I haven't resolved orange yet. Those become 3s. and well, now maybe I look at that between line, do I? Because I can see this digit. Oh, this is gorgeous. Right, look at this little cell here. Now, we've got the 5 in the middle of the between line, but this square sees 1, 2, 3, and 4. So this square has to be a high digit. In fact, let's see what it can be. I think it can be 6, 7, or 9. But the point is, this is therefore low, because it must be the other side of 5. But this sees 2, 3, and 4, so the only digit that can be is 1, which resolves that this is a 1, which you can see is now resolving that this is the orange square in this box, so that becomes a 3, that becomes a 3. Those two squares can lose their colouring. And have we done the puzzle now? This is a 6, 7 pair in box 7. This square is known. Look at that. That square's a 9. Just by simple old Sudoku. This square is a 6. By plain old Sudoku. 6. 6 in the middle box is in one of 2 places. These squares are... Have we not got 5s resolved yet? It seems not. Okay, so what have we not used? We've not used this clue, but we know approximately what it is. We know this is a high digit. 6, 7s and 9s, 6, 7s and 9s, 5, 6 and 9, 5, 7 and 9. Those two, 6s and 7. Oh, there's just loads of everything going on here. I'm almost thinking I'm going to have to colour the 6s and 7s. And possibly the 9s. That's interesting. Yeah, you see, this is interesting to me. I can see this square is in fact, look, I'm going to do this. I'm convinced enough. If I control A, I can delete the colours from the grid. Now, this square is interesting to me because you can see that this triple here is from 6, 7, 9, and this triple here is from 6, 7, 9. So whatever this is goes there in box 6 because it can't go there because of the knight's move constraint. So those two digits are the same digit. But you can see that means that's the same digit as that. So now these squares are 6s and 7s because this one sees 9. That means purple. Oh no, purple could be there. Ah. Oh, okay, but purple here must be there. I've got to be careful here because as I'm scanning, I'm sort of the given, or the digits I've placed, I'm ignoring in the scanning, which is not sensible. Yeah, here we go though. Look at box 3. This is purple, so purple is not there. This is purple, and it's 6 or 7. And it can't go there because it would be a knight's move away from itself. So this is purple, and we've got purple. Purple is 7. Yeah, lovely, lovely, lovely. This can't be 7 because of that one. So that becomes a purple 7. This must be a purple 7 now by plain old Sudoku. That must be a purple 7 by plain old Sudoku. How many 7s have we got? Almost all of them. Yeah, that's the last one. So that's 7. Turn it purple. That's become a 6. That's become a 6. Let's colour the 6s in. We'll use green. How many green 6s have we got? Some, but not all. Those are 6, 9 pairs. So green... Yeah, where does green go in the middle? It's got to go there. Which... that fixes the greens over here. Sorry, I'm being a bit slow about this. That's going to fix a green here. Which means what? Well, let's fill these in. Let's take the path of least resistance. That's green, that's green. We've now got a 9. Now we've got 9s to fill in as well. Let's make 9s red. So that's a red 9, which means that's a red 9. This is better. This red 9 sees that square, so that's got to be a red 9. And this has got to be a green 6 then. That looks like it's working. That forces this to be the green 6, this to be a red 9. Imagine if I find now that there's a knight's move discrepancy. Yes, I will cry on the camera. Now, oh, 5 in this box I've not placed. 5 was a different colour. Well, oh, I've sort of lost the colours of the 5s. But 5 has to be here. And this is a 6-9 pair. And that's a 9. And this is a green. So that means that's 6. That's 9. And let's just take a stare at this for a second and see whether or not it looks like... It looks to me like the 7s, 6s and 9s are not knight's moves apart. So I'm going to click tick. And I have solved it. Wow, nearly an hour in the heat. But what a puzzle that is. It's extraordinary. It really is. I mean, there's so little information in this. I mean, I understand why this has been requested, because that is monstrously difficult. And even once you get a little bit of start on the mad shape in the middle, the actual knight's move part of the puzzle it's unbelievable, the work that some of these digits are doing. I mean, literally, if I wasn't stuck, I would not have thought twice about looking at them. They just did not seem, it didn't seem possible they could do the work they did. And yet they do, and you can solve it, and it all sort of makes sense in the end. It's more genius from these incredible constructors. Take a bow, Gliperal. Thank you so much for watching. It's another long video, but I hope you'll forgive me. And we'll be back later with another edition of Cracking the Cryptic.